I'm Anil Kumar. Welcome to my series on complex loci. In this video, we'll consider 4 questions and we'll see how to sketch the Argand diagram representing complex loci. We have taken examples where the sketch is of a circle, it is of a line or a half line. So in these 3 examples, if the format is the absolute value of z minus a equals to r, where z and a are complex numbers, in that case you get a circle. If you have z minus a equals to z minus b, the result is a line, and if you have argument z minus a, I could say, equals to some angle theta, let me write down here. If you have the form argument z minus a equals to angle theta in radians, in that case what do we get is a half line. So for half line we have 2 examples. One, we have taken negative angle, and the other we have taken a positive angle, right? So negative pi by 4 and positive pi by 4. You can always pause the video, answer these questions, and then look into my suggestions. Now to begin with, let's be very clear. Whenever we are saying complex loci, we are actually looking into Argand diagrams. Correct? Not the Cartesian plane, where we will be plotting the real loci, right? Let us take these examples one by one. The very first one is of the form absolute value of x minus a equals to r. A complex number z is represented by the point P in the Argand diagram. Z satisfies absolute value of z minus 2 plus 3i equals to 5. Sketch the locus of P. So we'll take z as a complex number x plus yi. Now replacing this in the given equation, which is z minus 2 plus 3i equals to 5, we get absolute value of x plus yi minus 2 plus 3i equals to 5. Now we could rearrange and write this as x minus 2 being the real part plus y plus 3i as the imaginary part. Now the absolute value is x minus 2 whole square plus y plus 3 whole square root, right? Which should be equal to 5. We can square both sides and we get x minus 2 whole square plus y plus 3 whole square equals to 5. Now that gives you equation of a circle, right? So what we have here is equation of a circle with radius 5 square, right? With radius 5 and center at 2 minus 3, right? Perfect. So that is how the equation actually represents a circle. Now let's sketch it here. So on an Argand diagram, we have a real axis and an imaginary axis. Perfect. Real axis and imaginary axis. So we have a circle with the center at 2 minus 3, somewhere here, and the radius being 5. So the circle will be kind of like this. Correct. So here is an approximate sketch of the circle, where this point here will be 2 minus 3, right? So that point will be 2 minus 3. So we have this point as 2 minus 3i. And the radius of this circle will be equal to 5. Is that clear to you, right? So that is how we could actually sketch the diagram. So I hope the steps are absolutely clear. Now if you look at it, you can see very clearly that in the given situation, A is equals to 2 minus 3i, correct? So A is equals to 2 minus 3i, you get this equation, and that becomes the center of your circle with radius r, which is 5. Perfect. And in our case, r is equals to 5. Is that clear to you? So straight from the equation also, you can sketch the loci of the given complex number. Perfect. Let's move on and take the next example. Now here we have the form which is absolute value of x minus a equals to absolute value of x minus b. Both a and b are complex numbers. So the example here is, so once again, a complex number z is represented by a point p in the Argand diagram. Very important to remember, right? Z satisfies this condition that z minus 2 plus I is equals to z minus 2i. We need to now sketch the locus of points P. So we are given that it is z minus 2 plus I absolute value is equals to absolute value of z minus 2i. Now we'll once again consider z to be x plus yi. So we'll substitute z as x plus yi. So what we get here is x plus yi minus 2 plus I equals to x plus yi minus 2i. Absolute value, right? So it is x minus 2 plus y plus 1 I, absolute value, right, equals to, this is x plus y minus 2 I, absolute value. Perfect. Okay. So the absolute value magnitude is a square plus b square square root, right? So we have x minus 2 whole square plus y plus 1 whole square root. Okay, so we have square root on both the sides. Here we have x square plus y minus 2 whole square square root. Now we can square both sides and open these brackets. Square roots will go, right? So we'll square both sides. So what we get here is x squared minus 4x plus 4. Here we get y squared plus 2y plus 1. And on the right side we get x squared plus y squared minus 4y plus 4. Correct? We can now rearrange the terms, simplify. So you'll notice that x square cancels, y square and y square also cancels. So we can rewrite this equation as we have minus 4x, let's write down, minus 4x on the left side, then plus 4, plus 2y, plus 1 equals 2. On the right side we have minus 4y plus 4. Now bringing these terms together, let's say y is on the left side and all others on the right side, we get 2y plus 4y equals 2. We have 4x and then 4 plus 1 is 5, and we get 4 and 4 cancel, minus 1. So what we get here is 6y equals to 4x minus 1, or y is equals to 4 over 6x minus 1 over 6. And that is an equation of a line. Okay? So the line which we get is of slope 2 over 3 with y-intercept of 1 over 6. Is that clear to you? So you can always sketch this line to represent the locus of given points. So the equation will be, we have this point y-intercept as minus 1 over 6, right? And if I write the x value as, so it is increasing by 2 over 3, right? So going up 2 and 3, so we have a line which will move. Let's use a different ink to sketch this line. Right. Well, we can take a value of x equals to half, and then y will be equals to 1 over 6, right? So it is 2 over 6 minus 1 over 6 will be 1 over 6. So we can have a point here which will be half 1 over 6. So that way we can sketch a line with a slope 2 over 3 and the y-intercept of minus 1 over 6. Now let's move on and take the next example where we're talking about half a line. So the question here is, a complex number z is represented by the point P in the Argand diagram. For argument z minus I equals to minus pi by 4, construct the locus of z. So the type of argument is given to us is argument z minus a equals to theta. So whenever you have this kind of a situation, in that case, the result will be a ray moving in one direction. So the critical things to figure out here are two. One is the beginning, right? So starting point. And the other thing which you need to look into is direction. So I've taken up two examples to understand this concept. So we are given this question here, which is argument z minus I equals to minus pi by 4. So we can write this as argument x plus yi minus I equals to minus pi by 4. Let me club the terms together. We get x plus y minus 1 I equals to minus pi by 4. Correct. So that basically means that y minus 1 over x is equal to tan of negative pi by 4, and that is y minus 1 over x is equal to tan of minus pi by 4 is minus 1. Correct. So from here we do get the equation of the line, and the equation of the line is, let's rearrange. We have y minus 1 equals to minus x, and we can write this as y equals to minus x plus 1. Now you need to look into a couple of things here to actually sketch the ray. So we know one thing, if the y-intercept is 1, right? So that is 1 point. So we have a critical number here which is 1, and we also know that the argument is minus pi by 4, right? So since we have minus pi by 4, right? So that indicates a direction which it is moving in this particular way, because argument will give you the direction of movement. Perfect. So based on the given information also, you could sketch your graph, right? So this is basically the point I here, right? Imaginary. That is I for you, right? And this is real, right? So in imaginary scale, you have 1, which is I, right? And you get this particular sketch here. So definitely at x equals to 1 will have a 0, right? So that is how it is going to be. You could also test this particular situation. So to test, if x equals to 0, if x equals to 0, in that case, in this situation, we do not have angle of pi by 4, right? So if x equals to 0, we do not get argument of pi by 4. Let's consider this equation in the format of tan inverse y minus 1 over x equals to minus pi by 4. Okay, so I'm just rewriting it in this form, and you can clearly see when x equals to 0, in that case the argument is not pi by 4, right? So this is not true. Perfect, and therefore this point does not lie on this set of points P. Correct? Second, we'll also note that if x is negative and y is greater than 1, so if x is negative and y is greater than 1, we get a positive value here. Then also minus pi by 4 is not true. Correct? So both are excluded, and that is 4. So that is how you decide the direction. So that helps to check the direction of the half line, or you can say ray. Is that clear to you? So I hope that makes sense. Let's take one more example to understand this concept. Now in this example again, we have a complex number argument. The equation given to us is argument z minus 3 plus 4i equals to pi by 4, correct? Now pi by 4 means that the line is really moving upwards. So all these set of points are on the right side of your minimum value, right? So we could actually rearrange this by writing argument x plus yi minus 3 plus 4i equals to pi by 4, or we get argument x minus 3 plus y plus 4i equals to pi by 4, or we can say tan inverse y plus 4 over x minus 3 equals to pi by 4, correct? And from here we get y plus 4 over x minus 3 equals to tan pi by 4, which is equal to 1. So we get equation of the line here, which is y plus 4 equals to x minus 3, or y is equal to x minus 3 minus 4, y equals to x minus 7. So in this particular case, you could always sketch the loci on the Argand diagram, which will have imaginary along the y-axis, real along the x-axis, and as you can see, the y-intercept is minus 7. X equals to 0 is not valid, right? So if I write, now in this case, well, let's see the point which is to be considered, right? So what we have here is basically, if you look into this equation, it is argument z minus 3 minus 4i Is that clear to you, right? So that is the point given to us. So what you need to check is that when x is 3, so the critical point to check is when x equals to 3, right? So 3 and the value minus 4i means it is going to the point 3 and 4. So in this case, the critical point is 3 minus 4, right? 4i. So which is, let's say this is 3 for us, and that is minus 4, correct? So the point here is this point, and it goes in that direction. That is the half line. Do you get the idea, right? So the ray is actually translated to this point, which is 3 minus 4i. Is that clear to you? Now, you could actually test the result from here, that if you have x which is less than 3, and if I have y which is less than 4, in that case, if y is less than 4, let's say we have negative 5 here, so we get a positive value, right? So in this case, on the left side of this point, if we get a positive value, then the direction is not pi by 4, right? So in that case, argument is not pi by 4. I mean, I should write theta is not pi by 4. Is that clear to you? And also, you notice that for x equals to 3, tan inverse of y plus 4 over x minus 3 is not equal to pi by 4. Is that clear? So that is why here we have a hole, right? So I hope this point is clear. So the best way to draw this ray is to look for the translation. So z minus the complex number a, and that a gives you the position of the hole, and the direction is provided by the argument given to you, pi by 4 in this case, and that is how you could actually sketch your line. So I hope that makes sense. So in this particular video, we learn all about complex loci. So these are the points which are set of points which are drawn on Argand diagram. Depending on the type of situations, you could get a circle, a line, or a half line. And standard equations for a circle will be z minus a equals to r. For a line will be absolute value of z minus a equals to absolute value of z minus b. And for a half line, it will be argument of z minus a equals to the angle theta. I hope that makes sense. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.